Okay, this final video about limb controls will show you how we can use a single value, a single weight value, to control an entire limb. So I'm going to go to the limb control setup, and I'm going to do the same thing we did before. So create a limb control from the entire hierarchy, single curve. But rather than doing strength and damping, we're just going to use a single weight value. And I'm going to go ahead and create a limb control. So now we have a sort of stiff limb, like in the previous video. But now when we select the limb control, we only have one value, which is a weight value. And I'm going to simplify our explanation by coming to the attribute editor, and you know how we can decrease the value of the strength down the limb. What I'm going to do is I'm just going to make it so that the strength and damping are just constant across the limb, and update that. So right now we have a limb control, but we're not really decreasing the strength and damping as we go down the limb. So strength of the limb basically is at 4,000 all the way down this limb. But the strength is at 4,000 because my weight is at 1. If I put my weight at 0 and refresh, we get a super floppy limb. And the reason is when I look at each individual value, you notice that the pose strength is now 0. So basically all we're doing with the limb control is we're multiplying the weight by the base strength of the limb control. So we come to the arm control, the strength is 4,000, but the weight is now set to 0, so we're outputting 0 for every single point along the limb. Let's go ahead and change the weight to 0.1, and we'll come back to the attribute editor and we'll refresh. And now we're putting out 100 for the strength of each point down the limb, roughly. And the reason we're doing 100 is if we come to the advanced weight control here, you'll see that we have a curve. And we follow this curve to determine how we the weight is interpreted into the pose strength value. So I can edit this curve here. I'll show you these curve values. I'm just going to delete these curves here. So right now we've got a simple linear curve strength. So that might be the simplest way to understand it. So with a linear curve, now we're outputting 400, or 1/10 of the strength when we're at 0.1. And then when we go up to 0.5, we simulate, where you'll see that the limb actually snaps into place, because now each point on the limb is outputting roughly 2,000, right? Because we're not decreasing the strength as we go down the limb, and we're just weight 0.5, so half of the total strength of the limb control, and the total strength of the limb control is 4,000. Now the reason that you saw a strange curve to begin with is that typically you don't want to have such strong control of 4,000, but when you want the arm to be completely stiff, you need quite a high value. So by changing this curve to something that looks like this lets us have sort of weaker control when the weight goes between, let's say, 0.1, in this case 0.75, and then we get much stronger control as we approach 1. So now if I refresh, a strength of 0.5 corresponds to this behavior, and we can sort of see what a strength of 0.7 looks like. So 0.7 looks like this. And then, of course, 0.9 is now looking like that. So now it's quite strong. And 0 is still quite weak. So now you have 0 strength to 0. Obviously, you could make it so that if you want to have a 0 strength, you could come down to the limb here and say, no, actually, at 0, I would like there still to be some strength, for example, maybe. So now weight 0 is still going to output some strength. So now the weakest that a limb can get is like this. And obviously you can change what the maximum values are. So you can make this a more extreme ramp and maybe make this go up to 10,000, for example. So now this is strength weight 0, and this is strength 0.5. So what you have to do as an animator or a rigger, you have to tune how exactly you want your weight values to correspond to sort of what behavior you want them to correspond to. And you probably want to have this weight mapping in combination with what we covered in the last video, which is some decrease in strength of the pose strength and maybe a constant damping down the limb. So now we have a decrease in post strength down the limb and a nonlinear mapping of the weight to the strength based on this single value. And all of that, those attributes allow us to then use a single value, or a single weight value, which we can animate, and that controls all the post strength and all the dampings down the entire limb. So that's the more advanced weight-based setup of limb controls.